From where I stand, the Power BI bit, that has a shelf life. There's going to come a time when it isn't Power BI that's the tool anymore, it's some other tool. And sometimes we teach this with R and ggplot2 instead, and that's the same sort of idea. Ultimately, the tools have a shelf life, and that's true of any tool you will ever work with. The principles, these ideas, these concepts, these notions, they seem a little fluffier. It doesn't seem like there's, you're getting as much out of them, because a lot of it is like, well, talk, and let me show you something that I think works, and let me show you something that I think doesn't work, and so forth. So it's very opinion-based, but I think it's crucial for you to develop a good understanding of what constitutes an effective way to convey data information with charts. That is substantially more important than whatever tool you end up using. And a lot of this style, if you want, a lot of these notions that you'll develop, you'll only be able to develop them by trying things out and by failing at conveying the information you want to convey. And that's completely normal, it's completely acceptable. This is how you're going to become more than just part-time practitioners of the art. You'll become experts at conveying information with data. The Gestalt Principles are probably the closest thing we have to science on the art of data visualization, or visualization as a whole. It is somewhat debatable whether the principles work all the time, and it's not always easy to identify the times when they wouldn't work. So I wouldn't be willing to call it science, but I'm certainly willing to say that it's going to play the role of science for us. If you follow the Gestalt Principles when you create your charts, you are giving yourself the best shot at being able to convey information with data. Gestalt Principles help us basically apply the things we know about visualization, or how we process visual signals. Our perception is fragmented, right? Our eyes are basically continuously scanning the world around us, taking in inputs, and they jump around from one point to the next. There's two sort of ways. There are the preattentive processes, the things that we catch at a glance without really having to think about it. If you look in the upper picture, and I'm asking you to find the red dot, you will find it in seconds. You don't even need to think about it. There it is. It's right here. Attentive processes, on the other hand, are slow. They're deliberate. They're focused. They're forcing you to think about what you're seeing. They're engaging your long-term memory. If I'm asking you to find the red dot and the image at the bottom, you will eventually find it, right? It's this little thing right here, but it's substantially easier for me to find it because this is the 40th time I'm pointing it out. The very first time I'm looking for it, it takes me a while to find it. Somehow, the change in color, the contrast in color between red and blue triggers preattentive processes, but the contrast in shape triggers attentive processes. You do not identify the object that you're seeking at the same rate, at the same speed. In a sense, you want your charts to reward both of these channels, the preattentive channels and the attentive channels. Insights that you want the audience to get right away should be presented using principles that trigger preattentive processes, and insights that reward a second look, a third look, a further study should be presented using features that trigger attentive processes. Which means that you need to think about what it is you want people to get out of your charts. On the next slide, how many sixes? You don't have a choice, right? If you want to find out how many sixes there are, you need to go and look through the list and count them 1, 2, 3, one by one. This is triggering your attentive processes. There would be a very simple way to help people come to the answer. You highlight the sixes using a different color. We've seen that the color contrast is actually something that triggers a pre-attentive process. And it's very easy here to see the number of sixes. I just need to count the black digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. Paf. Took me no time at all. If I go back to this one, I literally have to look at every digit separately and make a decision as to whether it's a 6 or not. Now you see the difference here, right? One of those things jumps at you, the other one requires you to look into it. So there's a variety of pre-attentive attributes. We spoke, or at least I showed some of them when I talked about iconic memory. Things that jump at us. So if you have a change in line orientation, if everything else is oriented a certain way, and the important points, the things you want to focus the attention on, are oriented a different way, that will jump at people. If everything has a specific length except for the ones that you want people to focus on, that would also jump at people. The line weight as well. How bold, how thick are markers. Curvature, I have to tell you, perhaps it's the image that I've selected or the fact that I'm functionally unable to really see things. Definitely when I take off my glasses, all the curvature things look the same. So perhaps here you need an arc which is more pronounced. But that would probably be a way to identify a different type of point, to focus the attention of the consumer of the chart on a specific part of the chart. You can add marks, you can enclose points, you can change the color hue, definitely. Again, the intensity and the value might not be nearly as obvious on this chart. There's other things you can do, like if you're working with markers instead of with lines, you can add marks to markers to change them, enclose them, color them, provide a different intensity, a different shape. The shape isn't so easy to capture, right? It's hard to see that this point is different. At least not nearly as easy. The size definitely works well. The sharpness, no problem. Numerosity as well, where if we have small numbers, small collections of chunks, it's quite easy to tell that one of them doesn't have the same number of items as the other ones. If we go past a certain point, and studies say that basically if we go above 7, nobody really can count how many items there are anymore. If you show me a pile of 12 objects and a pile of 14 objects, I have to count them to see which one is larger. So we have specific ways to engage pre-attentive responses. So if there is something in your chart that you want people to focus on, you can use some of these attributes to trigger the pre-attentive response. They are the domain of the iconic memory. These are things that basically people see without even thinking about them. We've evolved to see them. Our brains have evolved to recognize these differences. It's good because they help us define a hierarchy of focus. Whenever these things are in your charts, they trigger a recognition, and this is what people will focus on. So if you want people to focus on something first, you present them with pre-attentive features. And another effect, another consequence of that is that anything which isn't highlighted there will be pushed into the background. In order for people to get insights from the stuff in the background, the stuff that is not highlighted, then you need to find a way to trigger their attentive features. You need to keep them interested enough that they want to look at the rest of the chart to see what else is out there to be seen. You don't want to overdo them, of course, because if you have too many pre-attentive attributes, then they get lost in a sea of pre-attentive attributes, and then you're back to the attentive step of determining which of the pre-attentive attributes you should be paying attention to. In Excel and R, it's quite easy to program your chart so that pre-attentive attributes will pop out. It's not nearly as easy to do in Power BI, although this is something that can be done. And so unless you have a clear-cut hierarchy, what you might need to do here is to produce a variety of charts that highlights different aspects in turn. But since you should never just be producing one chart to talk about a specific situation, right? You want to be able to look at it from different directions, different angles, Well, you can use the multiple chart setup to highlight various aspects of the analysis results. Basically, what these are, they're principles, laws of human perception. They help you understand how human beings, will group objects together and recognize patterns. Because this is really what data visualization is about. We're trying to find patterns in the data and provide the display to help other people recognize that these patterns were there. So they have to be able to recognize the patterns in your display to recognize the patterns in the data. If you look at graphic designers, and a lot of the time organizations will hire graphic designers to help come up with nice dashboards or nice websites. Graphic designers typically use the Gestalt Principles to produce something which will be both aesthetically pleasing and easy to understand. Now, one of my conceits is that you, as the data analyst / producer of at least the broad chart, should not be completely removed from the graphic design aspect of things. You want to avoid a situation where you've produced a dashboard and you hand off the dashboard to graphic designers. They weren't involved in the analytical process. They'll come up with a design and then push it up. The problem there is that if they haven't been involved in the analysis, you're not involved in the design, some of the wires might get crossed, and some of the highlights, some of the focuses, some of the insights will actually be mangled. You won't be sending the right message. Right? So you don't want to be completely isolated from the graphic design aspect. One of the ways in which you can make sure you will not be relegated is to actually produce dashboards that already take into account some of these principles. Gestalt is a German word, and it stands for unified whole. Everything you see, all the inputs you take in as one environment, not a collection of small components that make up an environment. What allows you to see the forest instead of a collection of individual trees. There are times when you want to see the individual trees. If you're trying to fight the emerald ash borer, you want to be able to identify trees that are ashes. But there's other times, if you're trying to save the forests or save the rainforest, you want to see the forest as a whole, an entity that needs to be saved. So we're talking about principles that are about 100 years old for some of them. Wertheimer, Kafka, and Kohler, you might have heard of the expression, the whole is greater than the sum of the parts. Well, that's a Gestalt expression. That you can help people visualize insights as a whole, a coherent whole, not just as a collection of independent and separate insights. Like, how do we perceive our environment as being like one environment? It's insane when you think about it. There's so many things around it. I look out the window, I'm seeing trees. I look out with my other eye here, I'm seeing a gallery of some portraits. I have my slides, I have lights, I have books. All of these are disparate parts. It's almost inconceivable that in spite of all these differences, I'm still feeling whole. It's one person in one environment. That the environment feels continuous. It doesn't feel like a disjunction of states. It's surprising that we can even do it. But it's not surprising because there's a good chance that our species would not have survived if we weren't able to do this. But it's very, very surprising. If you think about how it happens, you realize you have no clue that this is happening while it's happening all along. So let's think about some of them. The first one is the idea of simplicity. It would appear that our brain has a preference for simplicity. It's easier for us to process patterns that are simple than it is to process patterns that are more complex. We can still process complex patterns, but the cognitive load is larger, is higher. So if you're going to try to maintain simplicity, you'd want to arrange the data as simply and as logically as possible when you can do so. There are instances when you cannot do so. Like if you look at this bar chart here, on the left, main features, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 individuals with specific quantities associated with them. I'm going to color the individuals according to, well, some rule, which isn't really given here. It looks as though the ordering of the people is completely haphazard. And you're seeing, however, a chart. It's a chart that is parsable, that is readable. I can pick out the names, and I can actually look at the heights and say, okay, well, I'm getting a sense that Nutty is the highest value and then Amy is the smallest value. This chart is not a bad chart, but it's not the simpler way to present the information. Like, one of the things you could realize is that most of these colors are different. Even the greens, well, the greens are probably the same, although there's a slight variation. Possibly the colors mean something, but since each one of them has a different color anyway, probably I don't need to actually worry about the color. And I could rank them and order them according to their actual height. And when we do so, we realize that, it isn't just Amy that has the smallest height. Fred also has a height of the same thing. It's harder to see. Somehow my eye was drawn to the green and not to this weird peachy color. Would you agree that this second graph is actually easier to parse? Are you looking at both of these and thinking that there isn't really a difference? I think most of us would probably agree that this thing here is easier to parse. Now, if instead of people's names here we had an actual time series, an ordered set, where the sequence of events is important, well, we can't just order according to this descending quantities, right? Because the sequence of events matters. That takes over the need for simplicity. The next principle is the idea of continuation. When things are aligned, when there's a small difference from one observation to the next, when we can feel that something continuous is going on, not too varied, well, our brains have an easier time parsing the information. On the right, the eyes follow a continuous path. There isn't a lot of variation. And that makes the chart more readable, because everything is going downward or everything is going upward. Once we've established a pattern of going downward between the first 2 or 3 observations, our brains naturally assume that the rest of the pattern will also be going downwards, and it lightens the load to make sense of the chart as a whole. Whereas the chart on the left basically forces you to go left, up and down and up and down. There isn't a pattern that you can easily establish from the get-go, and that requires a continuously high cognitive load. We can never relax. You can never slip into the preattentive feature because you keep on having to parse the ups and the downs. If you can arrange the objects in line, it is going to facilitate grouping and comparison. Another principle is the principle of proximity. When you have objects or shapes that are close to one another, the brain naturally sees them as forming groups. So if you look at this collection of objects as a group, the effect that it generates is usually more powerful than the effect you would get by looking at each individual object separately. The whole is greater than the sum of the parts. This is where it comes from. So when elements are grouped together, they give you the illusion of higher level shapes, higher level clusters. Even if the elements are not touching, you'll view them as basically being touching. The lesson there is that if you understand the chart's priorities, what it is that you're trying to provide as information, as a message, then you can create groupings with the help of proximity to help you highlight these priorities. Let's look at a little example. What we see here is a disjointed collection of 9 gray squares. If you look at the image in the center, you might still see 9 gray squares, but even if you take just a little step back, definitely if I take off my glasses, the thing that jumps at me is that there's a big gray square. So proximity allows me to view these 9 objects as being part of a group. One of the ways in which you can use the proximity principle if you're working with financial or accounting data is to group by regions, and within each region by quarters. Or the other way around, right? You could also group by quarters first, and then within each quarter by region. But leaving a little bit of space between these things allows you to really view data as being, this is data for the north, this is data for the south, for the east, for the west, for each of the provinces, for each of the departments. But you can do it the other way around as well. This is all the quarter one data. Leave some space. Quarter two data. Quarter three, quarter four. You are reinforcing the fact that there is some collective property that these things have. Here it's a geographical property, everything in one region, or some temporal quality, everything in one quarter, rather than just having a bar chart where everything is equally spaced. Another principle is that of similarity. Things that look like one another are often viewed as being part of the same object. Things that don't look like one another are viewed as being part of a different object. When I say it like this, it sounds, formal, scientific, but this principle under a different name. It is basically the principle that underlies racism. If you can use similar characteristics in your charts to establish relationships, you'll encourage groupings of objects in the consumer's mind, which then will allow you to highlight specific aspects. If you look at these charts, I have here an array of 6x6 markers. What jumps at you in this array? Well, you should be seeing not an array of 6x6 markers, you should be seeing an array of 6 rows. The fact that all the white circles, if we see the white circles together, we see the black circles together, we're basically seeing rows. So if you want to highlight the rows in a table, you would color the rows and you would alternate row colors. If you're trying to highlight the columns, well, you do it the other way. You would literally color the columns. The same thing happens when we look at frequency counts given by little stick figures here. The fact that they all have the same color basically forces us to see them as being part of a row. Rather than seeing a collection or a column of 4 people here, we're seeing 4 different rows. It isn't just about rows and columns. Like if you make everything which is similar have the same color, it does reduce the cognitive load. I mean, there's no real reason to have these 4 things here colored differently. As a chart alone, the color doesn't carry any information except telling us that we're talking about different people. But we know we're talking about different people, we have different names for them. Another solution, if you really want these things to have different colors, because they're different people, well, you might want to use different shades of the same color, or different intensities of the same color. Too many colors engages our attentive processes, which means that the cognitive load becomes higher. When I say the cognitive load becomes higher, what I mean is it becomes harder for your consumers, for your end users, to parse the chart, to perceive it. But we can use that feature, that last principle, to really highlight specific things that are of interest to it. We can use the focal point principle. Is if everything is the same except for one marker, for one entry, or 2 entries, then these 2 entries really stick out. If you were trying to highlight one specific salesperson's performance, for instance, Peter in this chart, you use the first principles that we've seen, which are basically say you will order them according to height, so you have continuation, right? So that's a good approach to it. Then you would use the similarity principle so that everything has the same color. And the one that you want to highlight, you would give it a different shade or a different intensity. And then poof, right away you look at the second chart, the first thing you look at is Peter. You don't really need to think about it. But if I'm asking you to find Peter on the chart on the left, you literally have to go and say, where the heck is Peter? Where the heck is Peter? Okay, I found Peter here. You could put a big red arrow here over Peter. To be honest, that's just flat out ugly. You can't send that to your director, your DG, and ADM. We have cultural understandings about the use of colors, about the use of various charts. In the West, for instance, we read from left to right. In some cultures, that's not the case. I believe Arabic is read from right to left, and I think there's a few languages that are perhaps better designed to be read from top to bottom. Well, if you're speaking to a Western audience, you would take that into account, and you would present your information from left to right. If you're speaking to a Arabic audience, you might actually want to present the information from right to left. There's an isomorphic correspondence. Past shared experiences, conventions, make it easy for people to parse a chart because you don't necessarily want them to get outside of their comfort zone at the pre-attentive feature. At the attentive level, that's a different story. That is why, in spite of the fact that we think pie charts are horrible and should not be used, because they are used by convention in a variety of fields, it might not be a bad idea to use some pie charts here and then. Now, we are going to qualify that statement by saying, yes, you might want to use a pie chart, but if you do so, because you still have a role as a bit of an advocate, as an activist, you need to find charts that allow you to really convey the information, then you might also want to have a secondary chart or a tertiary chart that explains the same sort of things, but it is not shown in a pie chart format. When it comes to the choice of colors, this principle is also very important. Culturally, red is associated with bad and green with good. Green means go, red means stop. Yellow means careful, be careful. So you can color code your charts accordingly. If there's something that is bad that you want people to focus on right away, you color it in red. People will see it right away. Now that would be great, that would be ideal if it wasn't for the fact that red and green are nearly indistinguishable for people with various types of color blindness ailments. They'll just look like a big brown mess. So it might not be a bad idea to try to find other isomorphic correspondences. We know red and blue, right? Red means warm, blue means hot, even though in practice blue is hotter than red when it comes to fire or flames. So you need to try to find or use, if you want, these culturally established conventions. That might lead you to producing charts that are more boring than what you would like it to be. Another way in which isomorphic correspondence can actually be taken advantage of is your organization might have a set of colors that they already use. There might be colors that are specifically associated with your department or your organization, and then you can take those colors and have them be the accents, have them be the things that represent different things in your charts. That's another way to use isomorphic correspondence. What about the idea that colors carry emotions? Is this something you've heard of? Is this something you're familiar with? Apparently, some people view specific colors as being angry colors, as being happy colors. If it turns out that there's such a cultural convention around these emotions and colors, you might be able to use them to your advantage. But I'll level with you, this is not something that I'm familiar with. I don't know if purple is meant to be a sad color or a happy color. It's not something I understand. But if you have this understanding, you might want to take advantage of that. I trust that the examples that I've shown you really highlight how using the principles could make it easier to showcase specific points that you want your audience to focus on. The figure-ground duality, that one is a bit of an interesting one. When something is put in focus, something is a figure, by necessity everything else is seen by your brain as being part of the background or the ground. So there's a figure, the thing you're focusing on, and the ground, everything else on which you're not focusing. If you've put something into the foreground, you are promoting this object as being a focus object. And if you put something into the background, you are demoting the object. You're basically saying, for this chart, these other things are not worth looking at, or at least they're not as important to look at. If you want to make the duality between figures and ground very, very strong, you need to use strong contrast colors. You should make it easy for your brain to distinguish in a pre-attentive process which ones are the figures and which ones are the ground. So if there's enough contrast between the foreground and the background, that should not be a problem. Look at the chart on the left here. It is hard to tell what you're supposed to look at. And you can figure it out. If you use your attentive processes, you're like, Alright, so it's a bar chart. If you increase the contrast between the red background and the red bars by having literally a white background and red bars, you see it right away. It can work the other way as well. You might want to have a dark background and some light foreground, and usually we will be able to recognize very quickly that it's the light part of the chart that we're trying to focus on. Our brain is good at recognizing what's meant to be part of the focus, the figure, and what's meant to be part of the background. Usually whatever's bigger is considered to be part of the background because we think of it as being like the all-encompassing environment in which the chart lives. But if you arrange for the contrast between the ground and the figures to be strong, no matter if you decide to go dark for the foreground or dark for the background, people will be able to see the chart. One last principle that we'll talk about is the principle of the common fate. When your lines or your shapes come together, when they're in the same locations, say, or when they have the same directions, we usually perceive that a relationship between them exists, even if there isn't one. Lines that are askew, across the lines, are perceived as being somehow unrelated or less related to the original line. Now you'll say, well, hang on, sometimes the data is literally showing me that the lines are crossing. Like one line is increasing, the other line is decreasing. I gotta show that. Yes, you're right. But if you're showing so many crossings, people lose the illusion that this is all part of the same chart, the same data set. You have to suspend your disbelief. It's making people work too hard to parse the chart.